Have you ever asked an AI a question, received a confident, detailed answer, and then discovered that almost everything it said was wrong? Maybe it invented a scientific paper that never existed. Maybe it gave you a quote that nobody actually said. Or maybe it described a product feature, a historical event, or a piece of code with so much confidence that you didn't even think to question it. This is what people call an AI hallucination. But I think the word hallucination can be slightly misleading because the AI isn't seeing things that aren't there. It isn't confused, in the same way a human might be confused. What's actually happening is much more mechanical, and once you understand how a large language model generates text, these mistakes start to make a lot more sense. The most important thing to understand is that a language model is not primarily designed to retrieve truth. It is designed to predict text. When I type a sentence into a large language model, the model processes my words and estimates what token should come next. A token can be a word, part of a word, a number, or even a punctuation mark. It chooses one token, adds it to the conversation, and then repeats the process again and again. So if I type, "The capital of France is," the model has seen enough examples to know that Paris is an extremely likely continuation. That looks like knowledge, and in a practical sense, it is a form of learned knowledge. But the mechanism underneath is still prediction. The model isn't opening a database, locating a verified field called capital of France, checking that the information is current, and then returning the answer. It is generating the sequence of words that best fits the pattern. Most of the time, this works incredibly well because language contains a huge amount of structure. Facts are repeated across books, websites, articles, conversations, and reference materials. When the training data strongly and consistently connects one idea to another, the model can reproduce that connection very reliably. The problem begins when the correct answer is missing, unclear, rare, contradictory, or difficult to distinguish from incorrect information. Imagine asking a model about a famous event that appears in thousands of reliable sources. The statistical pattern is strong. The model has many examples pointing in roughly the same direction. Now imagine asking about an obscure local event, a small company, a little-known researcher, or a paper with a title that sounds real but doesn't actually exist. The model may have very little reliable information to work with, but it still has to generate something, and this is one of the biggest reasons hallucinations happen. Large language models are usually optimized to continue the conversation, not to stop every time they are uncertain. A human might say, "I don't know." A language model may instead construct an answer that sounds like the kind of answer a knowledgeable person would give. That distinction is extremely important. It may not know the name of a specific paper, but it knows what academic paper titles usually sound like. It knows how authors are normally listed. It knows how journals, dates, volume numbers, and citations are formatted. So it can generate a completely fictional citation that looks almost perfect. The model isn't necessarily trying to deceive me. It is completing the pattern. This is why fabricated information can sound so convincing. The model may be wrong about the fact, while being extremely good at the style surrounding that fact. It knows the grammar of confidence. It knows how an expert explanation is structured. It knows that a historical answer often includes dates, names, motivations, and consequences. It knows that a medical answer may mention studies, mechanisms, and possible side effects. It knows that a programming answer should include code comments and an explanation. So even when the foundation is weak, the presentation can still look polished. In some ways, better language generation can make hallucinations more dangerous, because a badly written mistake is easy to notice. A beautifully written mistake can travel much further. Another reason hallucinations happen is that the model compresses enormous amounts of information into its parameters during training. It doesn't normally store every web page as a perfect searchable copy. Instead, it adjusts billions of numerical values to capture patterns and relationships found in the data. You can think of this as a highly compressed representation of language and knowledge. Compression is powerful, but compression is not perfect. If I compress an image too aggressively, I may still recognize the overall scene, but smaller details can become blurry. In a similar way, a language model may capture the general relationship between concepts while losing the exact details. It may remember that a certain scientist worked in a certain field, but confused the year of a discovery. It may associate two similar historical events and accidentally combine them. It may understand the general structure of a software library, but invent a function that would logically belong there. This last example happens constantly in programming. A model may know that a library uses functions with names like createClient, load model, or generateResponse. If I ask for a feature that the library doesn't actually support, the model might invent a method whose name and syntax look completely reasonable. The code may even be internally consistent. It just run. This shows us that hallucination is not always random nonsense. Sometimes it is a plausible reconstruction based on incomplete information. The model is effectively saying, based on everything I have learned, this is what the answer should probably look like. Unfortunately, probably looks like and is actually true are not the same thing. The way we ask questions can also make hallucinations more likely. If I ask, which 2024 study proved that this treatment is effective? I have already implied that such a study exists. The model may accept my assumption and try to identify the study. Even if the premise is false, this is known as being led by the prompt. Humans do this too. If someone asks, why did the company cancel its project? We may begin looking for reasons before checking whether the project was actually canceled. Language models are especially vulnerable because they are trained to respond helpfully to the structure of the request. The more specific my false assumption is, the more material I give the model to build around it. I could ask for the authors, publication date, sample size, conclusions, and criticism of a non-existent study. The model may generate every section because each part follows a familiar pattern. This is why good prompting is not just about getting better writing. It is also about reducing false assumptions. Instead of asking, why did this event happen? I can ask, did this event happen? Verify the premise before explaining it. Instead of asking for 5 citations immediately, I can ask the model to separate what it knows from what it is uncertain about. But prompting alone cannot completely solve hallucinations, because the underlying model still generates probabilities rather than guaranteed truth. There is also a randomness setting involved in text generation. A model normally doesn't always select the single most probable next token. If it did, the writing could become repetitive and predictable. Instead, systems often allow the model to choose from several likely possibilities. This helps with creativity. It makes stories, brainstorming, and conversation more varied. But more variation can also increase the chance of factual drift. When I ask for a poem or a fictional character, creativity is useful. I don't need every sentence to be supported by a source. When I ask for a legal deadline, a medical dosage, a financial figure, or an exact quotation, creativity is the opposite of what I want. The same ability that lets a model invent a great science fiction world can also let it invent a believable but false reference. The challenge is not simply making the model less creative. It is making the system understand when creativity is appropriate and when accuracy must dominate. Another major problem is that the world keeps changing. A model's internal knowledge comes from its training data, and that training data has a cutoff. Even when a model has learned accurate information, that information can become outdated. A company can change its CEO. A product can receive new features. A law can be revised. A sports team can win another championship. A software library can completely change its API. If the model doesn't have access to current information, it may answer with an older fact. Sometimes it clearly says that its knowledge may be outdated. Other times, it blends old information with patterns that seem current and produces an answer that never existed at any point in time. This is one reason modern AI systems are increasingly connected to external tools. Instead of forcing the model to answer from memory, we can let it search the web, retrieve documents, query a database, run code, or inspect a company's internal knowledge base. This approach is often called retrieval, augmented generation, or RAG. The basic idea is simple. Before generating the final answer, the system retrieves relevant information from a trusted source and includes it in the model's context. Now, the model doesn't have to rely entirely on compressed memory. It can work directly with the retrieved material. This can dramatically reduce hallucinations, but it doesn't make them impossible. The retrieval system may find the wrong document. The source may be outdated. The model may misunderstand the passage. It may combine 2 documents incorrectly. It may cite a source that is related to the topic, but doesn't actually support the claim. So the problem changes from, did the model remember correctly? To, did the whole system retrieve, interpret, and present the evidence correctly? Tools help, but verification still matters. Training methods can also reduce hallucinations. After the initial training stage, models are often fine-tuned using human feedback, preference data, and carefully constructed examples. Trainers can reward the model for admitting uncertainty, following evidence, and refusing to invent missing details. The model can be taught that saying, "I am not sure," is sometimes more helpful than producing a complete answer. But this creates another difficult balance. If we make the model too cautious, it may refuse questions it could have answered correctly. It may fill every sentence with warnings. It may become less useful because it is afraid to commit to anything. If we make it too confident, it becomes smooth and productive. but it may invent details. Building a good model means finding the right balance between usefulness and uncertainty. And uncertainty itself is difficult for language models. The probability of the next word is not the same as the probability that the entire claim is true. A model might be extremely confident that a sentence is linguistically natural, even when the information inside the sentence is false. For example, the phrase, according to a 2023 study published in, may be a very predictable sequence of words, but that doesn't mean the study exists. The model's confidence in the text pattern can easily be mistaken for confidence in the underlying fact. That is why the tone of an AI answer should never be treated as proof. A confident answer is not necessarily a verified answer. A hesitant answer is not necessarily incorrect. Style and accuracy are separate dimensions. So, can hallucinations ever be completely eliminated? Honestly, probably not with today's basic language model approach, as long as a system generates answers from probabilities. There will always be some chance that it produces a plausible but incorrect continuation. We can make hallucinations less frequent. We can connect models to better sources. We can force citations. We can use specialized databases. We can add verification stages. We can let one model critique another model's answer. We can run code to check calculations. We can design systems that refuse to answer when evidence is weak. But reducing hallucination is different from guaranteeing truth. And this is where we, as users, have to change how we interact with AI. I don't think the right lesson is that AI cannot be trusted at all. That would ignore how useful these systems can be. The better lesson is that we should match our level of verification to the level of risk. If I am using AI to brainstorm video ideas, rewrite a paragraph, or create a fictional story, a small factual mistake may not matter very much. If I am using it for medical information, legal advice, academic research, financial decisions, or production code, I need to check the answer much more carefully. I should ask for sources, but I should also verify that the sources exist. I should check whether a citation actually supports the claim. I should test the code. I should compare important facts with official documentation or primary sources. And I should be especially careful when the answer contains extremely specific names, dates, statistics, quotations, or references that I didn't provide myself. Those details make an answer feel trustworthy, but they are also exactly the kinds of details a model can invent. The strange thing about AI hallucinations is that they are not simply a sign that the model is unintelligent. In some cases, they are a side effect of the same ability that makes language models impressive. The model can generalize. It can fill gaps. It can combine ideas. It can create explanations. It has never seen word for word. It can produce new text instead of simply copying a database. That flexibility is what allows it to write, summarize, translate, code, brainstorm, and reason across many different tasks. But the ability to fill gaps becomes dangerous when the gap should have remained empty. When information is missing, the most accurate answer may be silence, uncertainty, or a request for evidence. A language model, however, has spent its entire training process learning how to continue. So the next time an AI gives you an answer that is detailed, elegant, and completely wrong, remember this. It didn't necessarily fail to retrieve a fact. It may have done exactly what it was built to do. It predicted the next word, then the next word, then the next word, until it created an answer that sounded true. And in the age of generative AI, that may be one of the most important differences we need to understand. Sounding true is not the same as being true.